Welcome to Indiana's Get the Scoop ILEARN Mathematics training. We will discuss 5 important topics within this training. First, we will look at ILEARN as a summative assessment. Then we will share some key ideas about computer adaptive testing and the new items and rubrics for ILEARN assessments. And then finally, we will end with changes that are coming in accessibility and test administration. Let's begin by taking a moment to reflect on summative assessment. Not all assessments are created equal. The purpose of an assessment drives how it is created and how we should view and use its data. There are 4 main types of assessment: formative, interim, summative, and diagnostic. Each type of assessment has a different purpose and is constructed differently and should be interpreted differently. Formative assessments measure student knowledge and skills during learning so that instruction can be adjusted to target specific needs. Teachers use formative strategies like questioning, exit tickets, and rich tasks daily in the classroom to help move student learning forward. Interim or benchmark assessments monitor student progress over time. These may at times be placed into the formative or summative buckets depending on how that data is used. Summative assessments take place at the end of learning and provide evidence or measurement of what learning has occurred over a given period of time. Diagnostic assessments diagnose specific student needs for a certain skill set. All types of assessments provide data that's needed to make informed educational decisions. However, we would not look at the data from these assessments in the same way. ILEARN is a summative assessment, or an assessment of learning at the end of instruction. Summative assessments document the achievement or mastery of academic standards at a given point of time. These assessments provide large-scale data regarding program successes and challenges. This is very different from formative assessments, which are designed to inform teaching right there in the moment. Summative data is typically used to inform decision-making on a large scale, like identifying strengths and weaknesses in instructional or educational programming. Did my class or my school have overall strong achievement in math process standards? Which schools in my district are doing well in writing? Perhaps then we should share what they're doing. As a teacher, I might look at standard level data to determine what standards the majority of my students did well on, because then I probably have a really great system for teaching those standards, and then what standards my students typically struggled with. So maybe I want to target some PD for myself for some instructional strategies on those standards. Summative data might also be used as certification that standards have been mastered, or as one data point, among others, to determine program placement for students, or perhaps to flag students who may need additional support in order to achieve success. Summative data is not intended to advise teachers and students of next steps in instruction, as the data is just not specific enough for this purpose. Next steps are informed by formative assessment data. Summative data may be able to flag areas of student need and prompt teachers and parents to look more carefully maybe at a given area, but the data cannot provide next steps of instruction. Computer adaptive testing is new for Indiana when it comes to our statewide summative assessment. So let's discuss now how the computer adaptive or the CAT algorithm functions, as well as the key roles that are played by item rigor and item difficulty. Computer adaptive assessments were first built to meet an identified need, the need for more precise data about what students know and can do. Fixed form assessments tend to only measure student ability close to the average ability level, because all students are going to see the same test questions. Therefore, the range of difficulty does not venture much into too easy or too hard for the average student, creating a floor and a ceiling on the knowledge and skills that are being measured. Computer adaptive assessments overcame this difficulty by creating a way to individualize assessment difficulty while still measuring the same content for all students based on a test blueprint. What this means is that a computer adaptive test can measure more accurately the knowledge and skills a student has while still focusing on content priorities defined by that blueprint. This slide shows a visual diagram of how students could potentially move through an adaptive assessment. The left axis represents item difficulty. The more difficult items are higher on the scale than the easier items. The bottom axis represents the question number, so when you look from left to right, you can visualize how a student encounters different item difficulty as he or she moves through the test. You can see that all 3 students enter at a medium difficulty level. From there, the algorithm begins to adapt the difficulty of items based on performance. So if the student answers correctly, then they proceed to a more difficult question, and if they answer incorrectly, they move to easier questions. Notice that a pattern begins to appear with all test pathways about after item 8. Each line begins to level out. While this is not true across the board, the algorithm is typically able to identify average student performance levels around this point in the assessment, and then use the rest of the assessment to fine-tune. Item difficulty and cognitive complexity play very important roles in this adaptive algorithm. I will now hand the presentation over to Andrew Jones, our math content specialist, to discuss these topics and show some specific examples.
To best understand computer adaptive testing, it is important to know the difference between cognitive complexity, or the rigor required by a task, and item difficulty. These two concepts, although sometimes related, refer to different ideas. Cognitive complexity is a measure of the demand or thought processes required to complete a task. Bloom's taxonomy is one system that measures cognitive complexity by placing tasks into categories, such as remembering and understanding, low-rigor tasks, versus evaluating and creating, high-level tasks. Webb's depth of knowledge, or DOK, is another system that measures cognitive complexity. Tasks that only require recall or reproduction of information are low rigor, while those requiring strategic thinking are high rigor. DOK is the cognitive complexity measurement used for ILEARN assessments. Notice that cognitive complexity is always defined by the task that has been given. Whether a student finds the task to be easy or hard, the cognitive processes required to complete the task do not change. Difficulty is a measure of how hard or easy an item is based on how the students perform on that item. This is a statistical measure that may at times be related to the task given, but is not defined by the task. Many different factors may influence item difficulty, including the familiarity of the subject matter, linguistic complexity, numeric complexity, or the requirement for perseverance. While cognitive complexity and difficulty are at times related, they are not directly dependent upon one another. DOK may remain the same while item difficulty changes. Conversely, higher levels of rigor might include easy items, while lower levels of rigor may include hard items. Let's take a look at a few examples. Depth of knowledge 1 includes recall of mathematical facts, but not all facts are easy to recall. Even a simple question like, what is the value of pi, will be more or less difficult based upon the level of precision being asked. We wouldn't ask this question on a test, but it does a good job of highlighting how a depth of knowledge 1 item can have a range of difficulties. Recalling that pi's value is about 3 is easier than recalling 3.14, which is easier than recalling the value to 5 decimal places. There would be a range of difficulties based upon the same cognitive task of recalling information. Though you could estimate the difficulty based on the depth of recall, the empirical metric of difficulty would be statistical results of what percentage of students get the item correct. Depth of knowledge 1 often also includes the application of rudimentary mathematical concepts, such as using given information to calculate the perimeter of a garden. Here is a question that asks for a simple perimeter in a straightforward way. Depth of knowledge 2 involves applying these concepts to applications. In this question, you'll notice the word perimeter is never used. Students must apply the mathematical concept of perimeter to reach the solution, not merely recalling how to use the mathematical term perimeter. But it's worth noting that this calculation is not inherently any more difficult than the previous question. It is an identical calculation. But the increase in cognitive complexity means in this case that we would expect fewer students to get this question correct. So statistics obtained from the sample population would likely indicate that this is a more difficult question than the previous one, and gives us a quantifiable way of measuring the difference in the difficulties. It is also worth considering whether the cognitive complexity or difficulty of this item would be different if a graphic were included within the stimulus. This question involves applying the concept of perimeter again, but here the perimeter is part of a multi-step procedure to calculate the total cost of the fencing. Students must organize and sort more information, and there are a variety of possible solution strategies available. Again, no graphic is provided, although a student could certainly create their own graphic work as part of solving the problem on paper and pencil. The numbers are still relatively simple to work with, but the difficulty and cognitive complexity are both increased over the previous two examples. In this version of the question, the student again has to perform the same mathematics as before, but part of the scored response is also communicating the work as support of the answer. Here you can see an example of the same mathematical concept, a grade 4 standard about identifying, describing, and drawing various shapes, including parallelograms, with appropriate tools, approached at 3 different levels of cognitive complexity. The depth of knowledge 1 item is just asking the student to recall and reproduce the definition of a parallelogram. The depth of knowledge 2 item is asking the student to classify the shapes. Again, it is not more difficult than the level 1 task, but is asking for an application of the concept in a more robust way. The depth of knowledge 3 item is asking the student to generate an explanation or proof to justify a conclusion. They must draw on their knowledge of the definition of parallelograms to complete the task, but communicate that understanding in a clear way. It explicitly gets at the metacognition and reasoning behind the thinking that is being demonstrated implicitly in the depth of knowledge level 1 and 2 items. An algorithmic procedure like finding the mean of a clearly defined data set is an example of a task that is usually classified as depth of knowledge 1. The difficulty of these tasks can have a range based on the student performance on the items. Here are examples of 3 such items that we would expect to have different levels of difficulty based on the computations performed, even though they are reproducing the simple process of calculating an algorithm to calculate the mean of a given dataset. The first can be easily solved, perhaps even by simple inspection, if you recognize the symmetry of the set. The second is a bit more involved and difficult, but still merely a reproduction of the procedure for finding the mean, resulting in a division of 100 by 5 to get 20. The third example is again a reproduction of the procedure, but this time it involves dividing a decimal sum by 7, which is much more difficult. If we administered these items to students, we would anticipate the results from the sample population to correspond with these performance predictions. Some examples of what we might expect are here, though these particular items haven't been administered to students, so these aren't actual rates from Indiana students. We will now hear from Justin Mokas, another of our content specialists in mathematics, on performance tasks.
Now let's take a look at some of the new items that will be on the assessment and go over our updated rubrics for open-ended items. Each student will receive 1 performance task as part of his or her test. A performance task, or PT, is designed to provide students with an opportunity to demonstrate their ability to apply the knowledge and higher-order thinking skills to explore and analyze a more complex and authentic scenario. This performance task will contain one stimulus and several items aligned to either the Indiana academic content or process standards. The PT will be in its own segment. A performance task of 5 items will count toward the total of 48 operational items and leave 43 other items for elsewhere in the test. This example is from the Released Items repository. It shows the first item of the Grade 5 performance task. Authenticity is found in the context of planning material usage for a creative project. This is a content item assessing 5 AT2 and will be worth 1 point. The performance task items will be aligned either to content or process, but not both as some I-STEP items were in the past. The content items will always assess for on-grade level content standards. However, it is possible that an individual item that assesses a process standard may have content better aligned to a previous grade, so that a lack of content knowledge does not interfere with the assessment of process. The content and the CAP model will never exceed the current grade, even within process standards. The remaining balance of process items, according to the blueprint, can be assessed as standalone items within other segments of the test. These will not combine to make enough items for a reporting category, but they will still count toward a student scale score. Item number 3 of the Grade 5 performance task is shown on the screen. This is a sample of one of the open-ended and hand-scored items designed to build on the student's previous work in the problem and assess for Process Standard 2, reasoning quantitatively. The open-ended process items of the performance task are subject to a similar 2-point rubric like in the past. However, both points of the item contribute to process instead of a point each for content and process. While assessing process, the student must record a possible correct response in order to receive 2 points, which generally indicates a full and complete understanding. 1 point will be awarded for answers that either demonstrate a correct solution without justification or a logical conclusion while making a computational error. Previously, showing work was often the grounds for the process point, while a correct answer was the basis for a content point. Now, both of these facets may be scored together as 1 point, while an explanation or reasoning may be required for the second. Even if a student's work represents an actual attempt, 0 points may be awarded for answers that are completely incorrect or merely reference information from the problem. Rubrics will contain more specific details on a per-item basis, including not penalizing computational errors early in the performance task, later on dependent items. For more examples of scoring student responses to this item, please see the performance task demonstration video posted on the IDOE website. The new ILEARN blueprints replace the previous classroom guidance of critical standards or standards being check, check plus, or not assessed. However, insight can be gleaned from the minimum and maximum number of times a standard is assessed in the test. A standard with a minimum item occurrence of 1 will definitely be assessed on every student's test and may be inferred to be critical as determined by educator committees in the spring. It is possible that an item with a minimum range occurrence of 0 might not be assessed for all students, but could cycle up in the adaptive model for some. So at the next level, differentiating between standards that could appear up to 2 times versus the ones that cannot show up more than once may help an educator prioritize his or her plans. Also, it is important to note that reference sheets will no longer be provided for the test as hard copies or as an online tool. If a standard does not explicitly state the formula, method, or conversion, then it will be provided in the language of the item itself. If the blueprint was not fulfilled by the inclusion of a math performance task, a process standard will be assessed as a discrete item on the assessment. The example above was taken from the Grade 4 Process Standard 3 item specification on critiquing the reasoning of others. A response to a process item could be entered and scored in a variety of objective ways, including numeric response or multiple choice. Test blueprints are only one piece of test construction. Item specifications and performance level descriptors, or PLDs, also play an important role. Item specifications are discussed in a separate training, but let's spend some time now talking through the new ILEARN PLDs. Educator committees first create policy PLDs, or statements that define the overarching expectations for specific performance levels. Policy PLDs are then used to create range PLDs. Range PLDs take achievement expectations and apply them to each specific academic standard, showing what students need to achieve in order to obtain each performance level. These PLDs are then used to create items that will measure student achievement at different levels and in different ways. PLDs are not just part of the assessment development process, they also help us make sense of student scores. After students take the assessment, they receive a scale score. Scale scores describe a student's achievement of a set of standards as a whole. Meaning is attached to these scale scores through the performance level descriptors. Range PLDs can also help teachers, students, and parents understand what they need to know and achieve in order to reach different proficiency levels. The standard level descriptions of different levels of achievement may provide additional guidance on how students can achieve higher levels of proficiency. This screen shows the new ILEARN policy PLDs. Notice that we have 4 proficiency levels where our previous assessment had only 3. The new performance levels are below proficiency, approaching proficiency, at proficiency, and above proficiency. Remember, these are broad statements that describe achievement. They will be applied specifically to grade level content in the range PLDs. Let's take a moment to consider the similarities and differences between the performance levels. Notice that each PLD describes how well the student has met grade level standards. Below proficiency students have not met the standards, approaching have nearly met, and at proficient students have met grade level standards. Students above proficiency have not only met, but mastered grade level standards. Each category also references the level of knowledge, application, and analytical skills that have been demonstrated on the assessment. Performance levels also track college and career readiness. PLDs can be used to understand a student's overall achievement on grade level standards.
It is very important for any assessment to accurately measure what a student knows and can do. Accessibility is a key part of accurate measurement. And when I talk about accessibility in assessment, what I mean is that every single student should be able to accurately show what he or she knows. Nothing about the system, the items, or the way that the test is built should get in the way of that true and accurate measurement for all students. As we develop ILEARN, accessibility considerations are a priority. One aspect of this is tools or supports that can be provided to students during testing to assist them in accessing the assessment. IDOE has taken these tools and supports and created a framework to describe what supports are available and how they can be used. This is the ILEARN Accessibility Framework. You can see that tools and supports are divided into 3 main groups. Universal features are available to all students. Designated features are available to any student with a need that's determined by the teacher or school leaders. And then accommodations, which are available only to students with special plans. Embedded features are those that are provided within the online test platform. And the non-embedded features cannot be provided via the platform, and so they must be handled by the local school. Notice that several of these features are new for ILEARN. Let's take a moment to discuss a few of these new features so that we might understand how they can be used as supports. 3 universal features are new for all subject areas. The notepad allows students to take notes or jot down ideas as needed. The item tutorial is a feature that provides help on how to answer different item types in case a student is unsure of what to do. Item tutorials are specific to each item type. Glossaries are a new feature that specifically target accessibility. For all subject areas, content experts have identified words that all students might not know or understand, especially English learners. These words display on the screen with a slight blue outline. When students select the word, a glossary definition appears as is shown on the screen. It is important to note that construct-relevant words, or those words that students should know based on the standard that's being assessed, are never glossed. You can see a list of construct-relevant vocabulary for each academic standard in our item specifications. There are a few new designated features that I would also like to highlight. Translated glossaries are now available in mathematics, science, and social studies, as well as Spanish translations of test content. Translated glossaries work just like the English glossary, which is available to all, but they provide definitions in the additional language. The translated glossaries also provide audio versions of the word definition. This new feature allows students who may use additional languages at home to show the knowledge and skills that they have achieved without being confused by the language that's used in the question. Spanish translations are available to those identified with the need as well. These translations are stacked, so the Spanish stem is at the top of the screen and the English stem is below it, as shown on the screenshot. Answer choices are also displayed in both English and Spanish. If you would like to learn more about additional accessibility features and student accommodations, please consider viewing our Get the Scoop, ILEARN Accessibility and Accommodations training. You may notice that the calculator accommodation has been updated for ILEARN assessments. I'd like to take a few minutes to provide some background and explain conversations with our accessibility panel that led to these changes. An accommodation allows students to access a test, but it cannot change or impede the construct that is being measured. For certain types of questions in math, particularly those that measure computation and some aspects of number sense, the use of a calculator gets in the way of the intended measure of knowledge. That is, we are no longer able to assess whether the student has mastered these particular standards. For example, if I am measuring whether or not a student can multiply 2-digit by 2-digit numbers, and the student has access to a calculator, then I really don't know if the student can multiply or if the student knows how to use a calculator. The score report would no longer be an accurate portrayal of the student's skill, because we are unable to make inferences about their true abilities on that particular construct. Students could then potentially receive data saying that they are able to multiply when, in reality, they are not. This is a validity concern for our assessment. For this reason, no student, including students with IEPs and Section 504 plans, may use a calculator on certain non-calculator items. Because grades 3 through 5 highly emphasize computation and number sense as those foundational mathematics skills, no calculator is allowed for these grade levels, even as an accommodation. For grades 6 through 8, no calculator is allowed for non-calculator items, which is identified on each standard's item specification, including as an accommodation. For all other items, all students will receive access to a calculator. You might think about this accommodation as similar to text-to-speech. When measuring reading comprehension, passages and questions cannot be read aloud to students as it impedes the construct that's being measured. Similarly, when measuring computation and number sense, a calculator may impede the construct being measured and cannot be provided. You may notice that a hundreds chart for grades 3 through 8 and a 9x9 multiplication table for grades 6 through 8 are new available accommodations. As we prepare to wrap up, let's discuss a few important changes to note with the upcoming test administration. We are very excited about improvements being made in test timing. With ILEARN, there will no longer be 2 separate test windows, but rather there will be a single test window at the end of the school year. Students will experience a reduction of 1 to 2 hours of testing time per student on average. Assessment timing will be changing as well due to the computer adaptive nature of the tests. Students will be provided with unique test experiences based on how they performed on different items. Although all students will receive the same number of items for ILEARN, the difficulty of these items will vary by student. So to accommodate this, ILEARN assessments will not be timed, allowing students to work through the content at their own pace. Additional guidance regarding what this might look like and suggestions for scheduling will be provided October 1. I would also note that moving to untimed assessments can help to alleviate some concern regarding younger students typing responses, as these students will be able to take the time they need to respond. Test administration will look a bit different with the new assessment. Test tickets and seal codes will no longer be needed. The test administrator, either at the classroom, grade, or school level as locally defined, will create and start test sessions via the online system. This new test administrator dashboard also allows the administrator to monitor student progress as they work through the test. Those who will use the online system to start and administer tests must complete the required online test administrator certification course, which walks you through how to start and stop test sessions and also how to use the different tools that are available to test administrators. This training will be ready to go in the next few months. Scoring also brings us some exciting new changes. You need ILEARN data to be evidence-based and actionable, and we are working very hard to meet that need. Individual student results will continue to provide a scale score and subscores for reporting categories. Lexile and quantile scores will also be provided. These measurements define student achievement in reading and mathematics on a vertical scale that spans all grade levels. They also provide additional data regarding what students know and can do. For computer adaptive tests, standard level reporting will be available for aggregate level reports like classroom, grade level, and school data. This will assist teachers and administrators in identifying the strengths and weaknesses in curriculum and instruction. Also beginning spring 2019, Indiana educators are invited to be a part of the scoring process for our open-ended items. If you are interested in participating, watch for additional information to come through Dr. McCormick's weekly email. While we will not be able to provide student results in 2019 until after we complete standard setting in the summer, for all subsequent years, results for ILEARN will be provided within 12 days of students taking the assessment. This means that if a student completes an assessment during the first week of the test window, he will actually receive his individual results prior to the end of the test window. For iRead 3, results populate within 24 hours beginning spring 2019. Contact information for our staff at our office is included on this slide. Please feel free to contact us at any time with questions, concerns, or other feedback. We are here to support you and are always glad to speak with you and assist. Thank you for attending our training.